Alright guys, I'm going to get started. So today we're going to cover OOP. Okay. OOP stands for Object Oriented Programming. Okay. And this is what we call a design pattern. Which is a way of thinking about and organizing your code. Okay, so it's a way of designing your code, and a big part of designing your code is deciding how you want to organize things and how you want to think about things and how different things interact with each other. Okay, so that's in a very broad stroke way what a design pattern is, and object-oriented programming is one specific design pattern that is very common in web frameworks. Okay, so that's what we're gonna learn about it. So so far, you guys have been working with data structures and data structures and functions. Right? You have data structures, and you have functions. Right? So what are some examples of some data structures you guys have been working with?
Arrays.
Arrays, yeah. What else? Huh?
Tuples.
Tuples. Okay. Anything else? Huh?
Dictionaries.
Dictionaries, yeah. Okay. In addition to the data structures, you've also been working with sort of like, just like your integers, right? Your strings. These are not data structures, but they're data types, right? So we have this, right? And then we have our functions, right? And the way that we've been building things so far, those two have been very decoupled. Okay, so what I mean by that is that if you have a specific function, right, and you want to do something, and you want to use some data, how are you guys currently going about doing that?
Can you say that again?
Huh?
Can you say that again?
If you have a function and you have some data, and let's say your function interacts with your data, how are you guys currently doing that? Huh?
Route.
Oh yeah, so in a web framework, yes, you'll have a route for URLs, right? But also you have these functions, right? You have your parameters that are passed in, right? Your parameters. And then you'll do something with the parameters, right? Or you will have like just you're calling out that variable name, right? That you've already defined earlier, and then you're modifying that data as well. Okay, so that's how you guys are currently doing this. Okay, they're very decoupled. There's nothing that says you can't use this variable with this function, and if you have a function B or a function C, that can use the same data as well, right? They're all very like separate. You just decide what connects to what. Okay, so this is a very what we call procedural way of doing things. Okay, but because they're decoupled, they're kind of a little bit more disorganized in the sense that you decide how you want to organize things. You decide what function interacts with what specific piece of data. Okay, and another way to do it is to make it more coupled. Okay, so if what we were doing before is decoupled, okay, OOP is very coupled. Okay, what I mean by that is that the functions are very tied together to the data structures. Okay, they sort of come as a unit. You're grouping them together so that the data and the functions sort of are grouped together and they connect together. Okay. Let's see. Some other design patterns related to OOP are functional programming, and procedural programming. Okay, so we're not going to cover what these two are exactly, but I just want you guys to be aware that these are some alternative design patterns. Okay. So we're just going to be focusing on OOP. Okay, and then I also want to mention that we're going to be covering OOP as it relates to Python, so you guys have a general understanding of how OOP works. When you guys move to Django and Flask, OOP will sort of work on a different level. It will still be OOP, but it may be a little hard to recognize it as OOP. And so after you guys have gotten some experience with Django, I'll sort of go back and lecture again on sort of how that ties into Django. Okay, because you can actually do Django without really understanding how it's OOP and how it's actually all tying together, but it is OOP. And once you understand how it's OOP, things like sort of click a little bit more, and you can sort of understand how to manipulate things a little better. Okay, so I just kind of want to give that disclaimer. Right now, the stuff you're going to be learning is OOP, but you may not see the OOP-ness of Django until basically later. Okay, but we are covering it first because Django is OOP. All right, so I want to talk about what some of the hallmarks of OOP are. Okay, so here are some hallmarks. These are what I would consider the most important pieces of OOP. Okay, the first is that you have classes, and also that you have instances. You have attributes, which is your data / variables. And then you also have methods. Methods, which are basically your functions. And the last one is inheritance. Generally, the way you can think about this we'll just go through and talk about each of these. Okay, so these are the important parts of OOP. So the first is the idea of classes. Okay, so if you have a class, okay, the class is synonymous to a blueprint or a factory. Okay, and then you also have this concept of instance or object, which is the same thing. Okay, and this is like if we're working on a car. Okay, this would be like a car blueprint, a car factory. This would be the car itself. Okay, so if you have a blueprint for a car, okay, it might specify that the car has 4 wheels. It might specify that the car is a specific color, specific weight, has a specific type of engine, specific speed. It specifies what all those attributes are, okay? And then as like a factory, it can actually create those cars, okay? So you're basically putting all the specifications in the class, okay? And then you actually like make the object, you make the instance of the car itself. Okay, so you may have multiple Honda Civics, right? Like you have a blue Honda Civic here, that belongs to Tim, another red Honda Civic that belongs to me, or whatever it is, right? Those are all instances or objects of cars. They all came from like one car factory or one specification for what a Honda Civic is, okay, or what a car is. Okay, and so you have to basically like when you're creating these and working with OPR, you're going to be writing these classes. Okay, that describes what the specification is of what the cars will be able to do. And then when you instantiate them, what that means is you are creating an object for them, and that specific object will be actually have those specific attributes, that specific pieces of data, as well as the be able to do any methods that are associated with the car itself. Okay. And so back to this attributes and methods part, right? So attributes of a car might be, 4 wheels, right? This is an attribute that could be for all cars, right? But also another attribute might be like say the color. Okay, so while this is an attribute that may be on all instances of your class, this is an attribute that may only be on some instances of your class, right? I mean, they'll all have a color, but what color it is may be different. Okay, and so you can, even though everything, like all instances of a class may have share some similarities, right? Because they all come from that class. Specific attributes may also be different. Okay, so when we get into Django and stuff later, right? Another example is like a user class. Okay, so when you have a user class, right, you expect all users to have some similarities. Maybe they all have like an email address. They all have like a name. Right? But the specific data attached to that could be different, right? You'll have different email addresses and different names. But because they all belong to this class, they will all have these sort of attributes. And if you have methods that are attached to the user, for instance, the user can do something like log in or something like that, then that method may be attached to the user. Okay, any questions on this stuff so far? if you had a method like say driving forward on a car, right? It makes a lot of sense to attach it and group it together in this class because you don't. Driving forward is something that specifically a car does, right? So it's a method that you will only really be using relative to a car and relative to its data. So it makes sense to group it together so that you're not like trying to drive forward like a tree or something like that. So that's where sort of that grouping of it will be coming into play. So I covered attributes. Okay, the last one is inheritance. Okay, so inheritance is basically like, we have this car class. You may have subclasses of a specific class. Okay, so for instance, if I wanted to create a Honda Civic class, then I would create my Honda Civic class would inherit from my car class, so that, and maybe like I also have like a Toyota Camry class, right? They both inherit from the car class, so they both have some shared functionality. And if you want to define that functionality, you can define it in your car class. But then if you have some differences between the two, right, you might put those differences within the subclass. Okay, so you can just a way of sort of like structuring your organization. You might also have like a vehicle class and have like a car and a truck, right? So the truck has like a towing capacity and it has like some other things about it that other vehicles do not. And you specify that inside the truck portion, whereas something like driving that is like generic to both of them will be specified inside the car portion. Okay, so that's sort of the general concept of inheritance. You take specific functionality from one parent class and you move it to like a subclass. Okay, I want to show you guys what this looks like in code.